All right, today we're going to do lesson 8.5, and I told you at the beginning of this chapter that by the end of this chapter, you would have 3 different forms of a quadratic function. So today we're looking at that third and final form. The essential question for today says, what are some of the characteristics of the graph of f of x equals a times x minus p times x minus q? This is called the intercept form. Now, before we go any further in this lesson, let's talk about an intercept. We have talked about this before. So let's see what you remember. Can anybody raise their hand and tell me what an intercept is? Hey, Joshua.
Where the lines cross.
Where 2 lines cross, or where a point and a line cross, all right? So today when we're looking at intercept form, we're looking at the place where our graph is going to cross or intersect the x-axis. Now, right here, the first thing I put in your notes today are the 3 different forms. And I'm telling you right now, you will need this either on your quiz or your test or both. Okay? So I am telling you right now, highlight these 3 forms and make sure you memorize them. They are going to show up on the test or the quiz, or the test and the quiz. Okay? I haven't decided yet, but you will be tested over them at some point. So you need to know them. All right, you need to know them. But today, let's focus on the intercept form. Go ahead and highlight intercept form and then highlight the actual intercept form, which is down here in the notes. Okay, you're going to see that I highlighted the P and the Q because that's where your focus needs to be. The P and the Q are the intercepts of your graph. Okay, but before we get to that, we need to still be able to find the vertex. So far, in every single one of these forms, we have found the vertex and the axis of symmetry. So you can see very quickly in your notes that that is not changing today. We are still going to be finding the vertex and the axis of symmetry. So let's talk about the vertex. To find the x-coordinate of the vertex, you use the formula x equals p plus q divided by 2. Now highlight that because that's a brand new formula for you. We learned a little formula to find x for the standard form, but it was negative b over 2a. All right, so this is a brand new formula. If I'm looking at a problem and it is in intercept form, I have to use this little formula to find the x-coordinate. Now, without looking at the notes, without looking ahead, if you can help it, what do you think I'm going to do when I find that x-coordinate? What do you think I'm going to do with it so that I can find the y-coordinate of my vertex? Plug it back in to the original problem. Very good. So once I find x, I'm going to plug it back into the original problem, and I'm going to find the y-coordinate. Now, what have we been saying all along about the x-coordinate of the vertex and the axis of symmetry? They are what?
Related.
They are what? They're more than related. They are the same. Very good. So the only thing that is going to mess you up is if you do not write down the axis of symmetry correctly. So we talked about this yesterday. If you still don't have it in your brain, write it down in your notes today. Okay? It's an equation. When I ask for the axis of symmetry, it is an equation. What is that equation going to be? Every single time, how's it going to start? X equals. Perfect. Good job, Trey. So if you still don't know that, go ahead and write it down in your notes. It is x equals something. Okay? Why is it always x equals and not y equals? Because the axis of symmetry is what kind of a line? And don't tell me straight, because I know it's straight. A vertical line. And vertical lines pass through the x-axis. So it's always going to be x equals. Now, the value of x is the same as the x-coordinate of the vertex. And you see that here in your notes. Look at this. Use the formula x equals p plus q divided by 2. Well, we already used that formula to find the x-coordinate of the vertex. So obviously the axis of symmetry and the x-coordinate of the vertex are exactly the same. Now, the one extra thing today that you're going to find with intercept form is the intercepts. Okay? All along you've been graphing these parabolas, and I've been telling you, make sure you graph the axis of symmetry, make sure you graph the vertex, and pick 2 more points, right? I've been saying that. Well, now you have the 2 points that you need right in the formula. You have the 2 intercepts. But pay very close attention. See where it says pull out the opposite number. Remember yesterday in vertex form, we kept saying when you pull the x-coordinate out, when you pull the h out, you got to pull out the opposite of what you see. Well, that's the same exact thing here. Because look at the formula. The formula already has a minus sign in it. So if I'm looking at a negative 2, I'm really looking at a 2. Because the minus sign was already in the problem, okay? And we'll get to it here. We'll look at an example here in just a second. It'll make more sense, okay? Here's the last thing I want you to make sure you highlight, okay? How do I represent these intercepts? It's not enough to just say x equals 2 and x equals 3, okay? These are points. These are points where my graph crosses the x-axis. So the final answer needs to be an ordered pair. But we got to know what's going in the y spot. Okay, we've got the x spot. The x coordinate is right here in our formula. But what needs to go in our y spot? What is the y coordinate every single time going to be? 0. Okay, you've learned this along the way, and that's what I think some people aren't realizing. Way back when we needed to find the x-intercept, we had to make y equal what? We had to plug 0 into the equation and find the y-intercept. Okay, find the x-intercept. So it's the same idea. When you're writing down your x-intercepts, your y-coordinate will always be 0. All right? Now, let's practice this. The instructions, for example, 1 say graph the quadratic function, label the vertex, axis of symmetry, and the x-intercepts. Describe the domain and the range. But you're going to notice next to letter A, I put no Desmos. All right? Let's use the information that we just learned to graph this first one. So we don't need Desmos, so no phones out yet. Keep them in your pocket, all right? All right, now let's start with the vertex. All right, let's start with the vertex. And what was the little formula that we just highlighted in our notes that's going to help us find the vertex of this problem? Come on, look back at your notes. X equals P plus Q divided by 2. Hey, it rhymes. Okay, P plus Q divided by 2. So be very careful when you're pulling out your P and your Q. Remember, you're pulling out the opposite of what you see. So what is the P value in this problem? 2. Be careful, pull out the opposite of what you see. I see a positive 2, which means I'm pulling out a negative 2. Plus, what's the Q value in this problem? Positive 3. Good. I'm looking at a negative 3, so I pull out the opposite of what I see. And then I'm dividing it by 2. So, what is negative 2 plus 3? 1. And then over 2. All right? So, there is the x-coordinate of my vertex. So, I'm going to go ahead and start an ordered pair, and I'm going to put that 1/2 in it. But I need the y-coordinate of the vertex. So, what am I doing with the 1/2? Plugging it back into the original problem. So, we're going back to that original problem, which is f of x equals 1/2 plus 2 times 1/2 minus 3. Now, grab your calculators and do some math. What's 1/2 plus 2? 2.5. Okay. 2.5. And what's half minus 3? What's 1/2 minus 3? Negative 2.5. Very good. Now, what are we doing to 2.5 and negative 2.5?
Multiplying.
We're multiplying them. So tell me what you get when you multiply. Negative. We know it's going to be negative because a positive times a negative. But what is the answer going to be? Okay. 6 1/4. 6 1/4. Negative 6 1/4. Now, f of x is the same thing as what? As y. So that is the y coordinate of my vertex. All right, negative 6 1/4. Now, you can leave that as an improper fraction if you want. It doesn't really bother me. But just make sure that both of your coordinates are in the same form. All right, make sure they're in the same form. Now, the next thing it asks us to find is the axis of symmetry. So we've got the vertex. Somebody raise your hand and tell me the axis of symmetry. X equals 1/2. Remember, the axis of symmetry has to be an equation. So x is equal to 1/2. Because the axis of symmetry and the x-coordinate of the vertex are the exact same value. Now, the next thing it asks us is the x-intercepts. So we're going to go back to that original problem, and we should be able to very quickly pull out the x-intercepts. All right, what is the first x-intercept, Noah? Negative 2, all right? The first intercept is right here in the first set of parentheses. Remember, we're pulling out the opposite of what we see, so we're pulling out a -2. Now, Noah, what is the y-coordinate of that ordered pair going to be? If this is the x-intercept, it's crossing the x-axis at -2, what is the y-coordinate? 0, every single time. Awesome. Now, the second intercept is going to come from the second binomial in the original problem. Okay? Right here. So what is the second x-intercept, Anthony? Be careful. You pull out the opposite of what you see. So +3, and the y-coordinate will be 0. Awesome. So that's how quick we should be able to find and pull out our x-intercepts. Now, we got to go put all this on the graph. All right, we're doing this first graph without Desmos, so we're going to put it all on the graph. Let's start with the x-intercepts. -2, 0, I go left to -2, and I stay on the line. 3, 0, I'm going to go right to 3, and I'm going to stay on the line. Now, the instructions say label, so I've got to label this as 3, 0 and -2, 0. All right, next I'm going to do the vertex. So the vertex is a little bit tricky. It's 1/2, so I'm going to go from the center. I'm going to go right half. I'm going to go right between 0 and 1. And then my y-intercept is -6 1/4. So I go right halfway. Then I go down to the -6. And I'm going to go a little bit past that -6. But see how I'm right in the center between 0 and 1. Okay, so that's my vertex. And of course, I'm going to label it as 1/2. And then -6 1/4. All right, before I draw the parabola, I need to put my axis of symmetry. So we identified that as x equals 1/2. So listen, we know this, right? The axis of symmetry goes right through which point every single time? What's that point called? The vertex. It goes through the vertex every single time. Now, when it says label, we're going to label. You can label at the top or you can label at the bottom. It does not really matter to me as long as it's labeled. So x equals 1/2 is the axis of symmetry. Now, the only thing left for you to do is to actually draw the parabola. And remember, you want to be very careful. Make sure it is round and it is not a V shape. All right, and I'm very, very bad at this on here, so I'm very, very sorry. But it is a U shape. It is not a V shape. It's a U shape. Okay, don't forget the arrows on the end, because now I have to identify the domain and the range. What's the domain of this parabola? All real numbers. Awesome. And the range of this parabola is going to be what?
Y is 3 equal to -6 1/4.
All right, let's see if we all agree. First of all, we know it's y because it's range. Second, we know it's greater than or equal to because this parabola opens up. And the lowest y value on this problem is also the y-coordinate of the vertex, so -6 1/4. So he is exactly correct. So we box in the domain and the range, and we have just graphed this parabola without Desmos. Okay? How many of you loved that? All right. So for letter B, I want you to grab your phones. I want you to open up to Desmos, and I want you to graph. Remember, we have to identify the same things. We have to find and label the vertex, the axis of symmetry, and the x-intercepts. All right? So that has not changed, but use Desmos to do it. Remember, when you're doing Desmos, g of x can't go in there. You have to replace that with y. All right? So that's the first thing you want to remember. All right, let's talk about the x-intercepts. Who has found the x-intercepts, and what are they?
1,
Give me ordered pairs.
1 0 4.
Okay, we've got 1 0, which is right here, and what's the other one? Hold on, you said 1 0. Did you mean -1 0? If you're looking at Desmos, what are the x-intercepts? -1 0, which is right here, and 4 0. All right, so we plot them and we label them. 4 0, -1 0. All right, what's the vertex that you found?
1.5.
All right, so 1.5, you go right to 1 and then go halfway. And then I believe the y was what, 12.5? So yes, you're going to go a little bit off the chart. Go a little bit off the chart, but then you need to label it. So it was 1.5 and 12.5. Now again, I don't care if you use decimals or fractions. Just make sure that your coordinates are the same form. So if they're either both decimals or they're both fractions. Now the axis of symmetry. What is the axis of symmetry on this one? This doesn't show up on Desmos. So this one you have to figure out yourself. Where does the axis of symmetry go? Good. It goes through the vertex. So it's going right down the center between 1 and 2. Okay, you put your arrows. And if we're going to label this, how do we label it? What is the axis of symmetry? It's not just a value. It's x equals 1.5. Awesome. All right, and the only thing left to do is draw your parabola. Does this parabola open up or down? Down. See, look how bad. I'm just so bad at this. Sorry. My word. There we go. All right. Make sure the parabola is rounded and not V-shaped. All right. Now, the last thing we got to do is the domain and the range. What is the domain of this parabola?
All real numbers.
Good. All real numbers. And what is, somebody raise your hand. What is the range of this one? Let's see what somebody can do on this one. TJ.
Y is less than 12.
Keep, not 12, 12.
12.
What's that highest y value? It's the y coordinate of your vertex.
12.5.
12.5. Very good. But it is less than or y is less than or equal to because the parabola opens down, and then that very highest y coordinate is 12.5. All right. Now, let's move into, and this is what it looks like on Desmos. Let's move on to finding the zeros. Now, you need to add this to your notes because it's not in your notes. Zeros and x-intercepts are the exact same thing. So just like I can swap y and f of x, I can ask you to find the zeros or the x-intercepts, and I'm asking you for the same thing. Okay, so add that to your notes. Finding the zeros. What are zeros? Zeros are the x-intercepts. Now here's the good news. This is not new to you. The only thing that's new to you is step number 1. You have to make f of x equal 0. Okay, you're replacing f of x with 0. Then, if the problem is not factored, you have to factor it. Then you have to set each set of parentheses equal to 0 and solve for x. Guess what? You did that on your test a week ago. So the only new thing that you are learning is replacing the f of x with a 0. So look at letter A. F of x is going to become what?
0.
0. And we're going to bring down the rest of the problem. It equals x minus 6 times x minus 1. Now, what are the two equations that we're going to set up?
X minus 6 equals 0.
X minus 6 equals 0 and x minus 1 equals 0. Because guess what? They already factored this problem for us. We do not have to factor. How do we solve for the first x? We add 6. Awesome. So x equals 6. How do we solve for the second x? We add 1. So x equals 1. Now, I boxed in the first one and I shouldn't have. Here's why. My final answers, if these are zeros, if these are x-intercepts, my final answers should be in what form? An ordered pair. These are points, right? These are x-intercepts. They're points. So what is the ordered pair going to be for x equals 6? 6, 0, and that's what I'm going to box in. And for x equals 1? 1, 0. Good. So the only extra thing we're going to do, we're going to make sure our final answer is an ordered pair. All right, let's look at letter B. Now this says g of x. Does that change anything? Or I'm still going to replace g of x with what? 0. Good. Now, has this problem been factored for us?
No.
No. So we got to talk through the 4 questions we ask ourselves when we're factoring. Okay? See how we love things that we've learned before when they show up in our new lessons. All right? That's why we got to learn it. Can't just try to memorize it for a test and then forget it. We got to keep it in our brains. All right, what is the first question that we ask ourselves? Is there a GCF? Yes, what is it? 3. So we pull it out and we divide. 3x squared divided by 3. X squared, bring down the minus sign. 12x divided by 3 is 4x, bring down the plus sign. And 12 divided by 3 is 4. Question 2, what type of polynomial are we now dealing with? Trinomial. Question number 3. What is it? Is there a shortcut? Now, it's a trinomial, so there's only one type of shortcut. Is this a perfect square trinomial?
No. Yes.
Yes, it is.
Yes, it is. Now, we think it appears that way, so we're going to treat it as if it is a perfect square trinomial. So we're going to bring down the 0 equals. Now, if this is a perfect square trinomial, how many parentheses are going to be in my final answer?
2.
Okay? No. 1. For a perfect square trinomial, it's one set of parentheses, and that is raised to what power? 2. All right? Now, we find the square root of x squared, which is x. What's the sign in our answer going to be? Minus. And what's the square root of 4? 2. Now, how do we check to make sure this actually gives us the middle term? 2ab. So let's do that over to the side. 2, what's our a? X. And what's our b? What is 2 times x times negative 2?
Negative 4x.
Is that my middle term?
Yes.
Then I'm good. I'm factored. That is a perfect square trinomial. Now, I have equations to set up. What's the first one I'm going to set up?
0.
3 equals 0, right? Every single term gets an equation. So 3 equals 0. Now, does that even make sense? Is that true? No. So we cross it out. We don't need it, but we still have to write it. What's the second equation we're going to write down?
X minus 2 equals 0.
Okay. How do we solve for x?
I'll add 2 on both.
We add 2 on both sides. So x equals 2. Now, what's our final answer going to be? 2, 0. The ordered pair, 2, 0. Now, let's talk about this for just a second. Look at letter A. If I have 2 x-intercepts, how many times is this parabola going to cross the x-axis?
2 times.
2 times. All right? Look at letter B. If I only have 1 x-intercept, how many times is that parabola going to intersect the x-axis? Once, okay? So tomorrow, you're going to find the zeros, and you're going to use them to help you graph. So I just want you to keep in mind, sometimes the parabola will cross the x-axis twice. Sometimes it'll cross it once. All right? So that's not a strange thing if you see that happen tomorrow. All right? Now, an example number 3. It says, write a quadratic function in standard form. It's very important that you understand they want the final answer in standard form. Now, whose graph satisfies the given conditions. So they want the final answer in standard form. It doesn't mean we're going to start with standard form. And we've only learned 3 forms. So this should not be too difficult. All right, look at letter A. It passes through 0, 0, 10, 0, and 4, 12. Now, before we do this, actually, let's write down standard form so we know what we want our final answer to look like. Who remembers or can look back and tell me standard form? F of x equals ax squared plus bx plus c. All right, so this is our final answer, needs to be in this form. All right, but we can't start with that form because all we have is 3 points. All right, so we've eliminated standard form. What's the next form that we could use to start this problem?
Vertex.
Vertex form. Okay, good. Any way to tell which of these is our vertex? No. So we can't use vertex form. So the only form left is intercept form. Are any of these ordered pairs our intercepts? I hear yes. All right. Yes. 2 of them are your intercepts. But the question is, which 2 are your intercepts? Listen, this is why I pointed out at the beginning, it's very important that you understand when you have an x-intercept, what is the y coordinate every single time? 0. So which of these 2 ordered pairs are your intercepts?
0, 0, and 10, 0.
0, 0, and 10, 0. So very good. Let's write down the intercept form. F of x equals x minus p and x minus q. Now you notice I left the a out. A for us in this problem is a 1. So we don't need to put it. Okay, so we're really focused on the x minus p times the x minus q. Now, what is the first intercept? F of x equals x minus 0. Good. Times x minus, what's the second x-intercept?
10.
4.
10. Okay? We already identified the intercepts as 0, 0, and 10, 0 because x-intercepts have to have a y-coordinate of 0. All right? We've got to simplify the problem. We've plugged in what we know. Now we've got to simplify it. Okay? If we didn't know anything else, how do we multiply two binomials? Go back to the beginning of chapter 7. FOIL. Okay? So if we didn't know anything else at this point, we would FOIL. However, that's x minus 0. What is x minus 0? X. So we can actually simplify our lives a little bit by just rewriting that as just x. But I'm still not done because there's still more I can do. What can I do here? I can distribute that x, right? I can distribute the x. So what is x times x?
X squared.
X squared. And we'll bring down the minus sign. What's x times 10?
Negative 10x.
10x. Now is it in standard form? Yes. All right, and that is my final answer. Now, look at letter B. Letter B we should be able to fly through very quick. They give us a vertex. Which form can we plug this into? Vertex form. So f of x equals x minus h squared plus k. Now, a couple things. If that is a period on your notes, it should be a comma. Then remember, vertex form. The vertex is the ordered pair hk. Okay, that's important when you're going to plug these numbers into this formula. So f of x equals x minus, what's our h value? 8 squared plus what's our k value?
8.
Awesome. Now, got to go back to the beginning of chapter 7 again, where we multiplied special products. Do you see a special product in this problem? A square of a binomial, right? So, how do we multiply this quickly? First of all, f of x equals, good, we're going to square the first term. So we're going to square x and we're going to get x squared. How do we find the middle term? Listen, think back to what we just did when we were factoring and we were checking the middle term. How do we find the middle term? 2ab. Very good. So what's our a this time? X. And what's our b?
8. Negative 8.
Negative 8. So when we multiply those, what do we get? Negative 16x. So guess what? That is our middle term. And then the last thing we have to do, Josh Eisenberg, we squared the first term. We did 2ab to find the middle term. So what's our third and final step here? No, we're not done. We've squared the x. We found the middle term. What's the only thing left in that binomial that we haven't squared yet? We square the 8 and what do we get? 64. Now, we got to bring down the rest of the problem. So, are we finished? No, because we have to combine what? And our like terms are 64 and 8, which make 72. And that is lesson 8.6.